Hi everyone, my name is Rasha May Pepito. Currently in my first year in college. In our NSTP 002, students are supposed to have an outreach program. But due to the pandemic, we were able to conduct a community work. So as displacement, we are tasked to make a video tutorial about our chosen topic, which is for me is illustrating about the quadratic equation.
Came from Latin expanse. Quadratic it's called constant square since it does not have or contain any modifiable variable, unlike the previous two terms. So, our lesson for today is about illustrating the quadratic equation. But before we start, let's identify first what is quadratic equation. As shown in your screen, a quadratic equation is an equation which is in the second degree, meaning the degree of an equation should be raised to 2. But how can we determine if the equation is a quadratic equation? It is determined through the highest exponent of the variable. Therefore, in this equation, the highest exponent in our variable is in second degree, which is the ax squared. Another thing is, a quadratic equation can be written in the standard form, which is the ax squared plus bx plus c equals to 0, where a, b, and c are real numbers, and a is not equal to 0. So again, we have ax squared plus bx plus c equals to 0, and the ax squared is called the quadratic term. It came from a Latin word quadratus, which means square, and in our equation, the exponent is written in the second degree, which is the ax squared. On the other hand, this one is called the linear term. It is a term with a degree of 1, or simply x, which is commonly seen in a linear equation wherein the equation is raised to the power of 1. Lastly is the constant term or the fixed value. It's called constant term since it does not have or contain any modifiable variable, unlike the first two terms. So before we proceed, let's have a test first. You will see on the screen the equation I provided, and you may write your answer on a piece of paper. Your task is to determine whether the equation is a quadratic or not. If you need more time to answer the following, you can pause the video for a minute or until you finish answering. So here's the correct answers. But let's talk about first about the quadratic equation. So in 2x squared minus 4x minus 2 is equal to 0, this is an example of quadratic equation since it was written in a standard form, which we tackled earlier. So let's proceed to the three remaining equations. Do you think it's an example of quadratic equation? Yes, it is. As a matter of fact, it is an example of an incomplete form of quadratic equation. In this case, the quadratic equation will be considered as long as the quadratic term is not equal to 0, which leads to the 3x minus 6x squared plus 1 equals to negative 6x squared. So we combine like terms by transposing negative 6x squared. Then it will become positive. Then positive 6x squared minus 6x squared, it will become 0. Therefore, our quadratic term is equal to 0. And once it becomes 0, then it's not an example of a quadratic equation. Like what I said a while ago, in a quadratic equation, the highest exponent of the variable should be in the second degree. So in this case, what is the exponent of the equation? Yes, 1, meaning it's not an example of a quadratic equation, but rather a linear equation. Same with the 4x minus 2 equal to 8. Last is the 5x multiplied by x squared minus 8 is equals to negative 2x. Why do you think it's not considered as quadratic equation? Yes, because when we apply the distributive property, 5x times x squared, we will get an answer of 5x cubed, which is not a quadratic equation since the highest exponent is 3. On the next slide, Here are the steps in writing a quadratic equation in standard form. Step 1. If it's written as factors, find the product applying the mathematical concept on special products. But if it's not written as factors, you may proceed to step 2, which is to transform into the standard form ax squared plus bx plus c equals to 0, applying the transposition rule, wherein once the number was transposed to the other side, or in the equal sign, or what we call fulcrum or balance point, the sign will be changed from positive to negative or negative to positive. So for further information, I have here examples that we need to answer. In our first example, we need to write the quadratic equation 3x multiplied by quantity x plus 3 equals negative 2 in standard form ax squared plus bx plus c equals to 0. Then, find the values of a, b, and c. So, the given in this example is the 3x multiplied by quantity x plus 3 equals negative 2. And since it was written in factor, we could apply the step 1, which is the application of mathematical concept, particularly in distributive property. We can apply this by multiplying 3x to the quantity x plus 3. So, 3x times x is equals to 3x squared. And 3x times 3 is equals to, 9x. Therefore, we have 3x squared plus 9x equals negative 2. So, proceed to step 2. You need to transpose negative 2 to the other side by changing the sign into positive, since it go beyond the balance point. From there, we have 3x squared plus 9x plus 2. Is it already in standard form? Yes, because we already have the quadratic term, linear term, and the constant term. So now, we can get the values of a, b, and c. So for the value of a, we have 3. And for the value of b, we have 9. And lastly, for the value of c, we have 2. In example number 2, write the quadratic equation x plus 2 multiplied by quantity x minus 3 equal to 0 in standard form ax squared plus bx plus c equals to 0. Then find the values of a, b, and c. So again, the given in this example is x plus 2 multiplied by the quantity x minus 3 equal to 0. And since it was written in factor, we could apply the FOIL method. We need to expand the product by multiplying the quantity x plus 2 to the quantity x minus 3. So to get the quadratic term, we need to multiply the x from x plus 2 and x minus 3. So as we can see, there's no numerical value written in this, but that doesn't mean that it is equivalent to 0. As a matter of fact, x is equivalent to or same with 1x. However, when it comes to the exponent, we will not get the product of the exponent, but rather the sum. And from there, we will get an answer of x squared. Next, we will get the linear term. And this is the sum or difference of the outer and inner part of the equation, depending on the equation. And in our equation, we have positive 2x and negative 3x. And since the negative is higher than the positive, we will get an answer of negative 1x or simply negative x. Lastly is the constant term. In order to get the constant term, we need to multiply 2 by 3. So we will get a result of 6. All in all, we have x squared minus 1x minus 6 equal to 0. So my question is it already in standard form? The answer is yes. So a, or numerical coefficient of x squared, is equivalent to 1, while the numerical coefficient of x is equivalent to negative 1. And lastly, our constant term is equivalent to negative 6. For example number 3, write the quadratic equation quantity x plus 4 squared equals 0 in standard form ax squared plus bx plus c equals 0. Then find the values of a, b, and c. So our given is the quantity of x plus 4 squared equals 0. In this equation, we could apply the Fol method and the concept of expanding square of binomial. So for us to better understand the problem, we're going to expand the problem. Then we will have a x plus 4 multiplied to the quantity of x plus 4. So same with the number 2, it doesn't have a numerical value. So our quadratic term will be x squared. While the linear term is the sum of 4x plus 4x, which is equals to 8x. So lastly is the constant term, which is the 4 times 4, which have a result of 16. Therefore, we conclude that we have x squared plus 8x plus 16 equals 0, with 1 as the value of a, 8 as the value of b, and 16 as the value of c. So in summary, a quadratic equation is an equation which is in a second degree. So the thing that we need to remember here is the ax squared plus bx plus c equals to 0, since it is the standard form in our equation. We encounter some instances about the incomplete form of quadratic equation in the future. So the incomplete quadratic equation is the form ax squared plus bx plus c equals to 0, and either b is equal to 0 or c is equal to 0, as long as the quadratic term will not be equal to 0. Another thing is the steps in writing a quadratic equation in standard form. This will help you to expand or better understand the problems or equation you may encounter in the future by forming the standard form first and then getting the values of A, B, and C. So that's all for today. I hope you learned something
Yes,
from me.
I hope I will be able to help you. So to wrap it up, that's all for today. Thank you for watching and good luck and class dismissed.